Hi, in this lecture video, I'll be discussing one of the reactions of alcohol, and this is the reaction that can be used to change an alcohol into an alkyl halide. Now, there are a variety of ways how we can change an alcohol into an alkyl halide. For an example, hydrohalogenation reaction of an alcohol. But normally, hydrohalogenation reaction of an alcohol would only be efficient if we were to have a tertiary alcohol. If we were to have a primary or a secondary alcohol, it would be difficult to change that into an alkyl halide because of side reaction. So in this lecture video right here, I'll be sharing with you two chemical reagents that are quite effective in changing a primary and a second alcohol into the corresponding alkyl halide. And those two chemical reagents are first thionyl chloride with the chemical formula of SOCl2, and the second one is phosphorus tribromide. So these are the two chemical reagents right here. Thionyl chloride would be able to convert an alcohol into the alkyl chloride, versus PBr3 will be able to convert an alcohol into the alkyl bromide. But before we get going to go over these two reagents right here, let's discuss why do we want to be able to convert an alcohol into an alkyl halide. Well, synthetically speaking, this is useful because we know that alcohol are not very good substrate because this OH right here is not a good leaving group. So anytime that we need to convert an alcohol into a good leaving group, then that when we can see that it will be useful to be able to convert that into the alkyl halide first. And so these are the two chemical reagents right here that will allow us to convert a primary and a second alcohol into the alkyl halide. So now let's talk first the thionyl chloride. So this is the chemical reagent right here to convert an alcohol into the alkyl chloride. The chemical structure of thionyl chloride is as follows. So the sulfur is double bonded to the oxygen and single bonded to the 2 chlorine. And based on this chemical structure, we can see that this sulfur right here is a good electrophile. So thus, when we react this with the alcohol will be acting as a nucleophile, coming to attack this sulfur and breaking one of the pi bond between the sulfur and the oxygen. And now the electron go to the oxygen. So this is the nucleophilic addition step right here. And the product of this step is as follows. And this is not a very stable molecule. So what will happen is that the electron will go back down to form the double bond to the sulfur, and this will then eliminate the chloride and making this chloride fall off right here, and restoring the double bond between the sulfur and the oxygen, and followed by the proton transfer. And we still have our chloride floating around in solution. Once we have produced this intermediate right here, this entire group is now become a good leaving group. And the reason why it is a good leaving group is as the following. If we were to imagine this bond were to be broken, and now the electron go to this oxygen would then be able to donate the electron to this sulfur right here to form resonance structure. It can also kick up this chloride right here to make this complete fall off, and now form an SO2, which is a gas, and also this chloride anion right here. So because the chloride, when it fall off, is a good stable molecule. So that's one of the driving force that push this reaction forward. And the second would then be the formation of this SO2 gas. So this gas will simply bubble out solution. And thermodynamically speaking, that can push equilibrium to the right side as well. So that's the reason why this is a good leaving group. And once we have this already, the chloride, which is now a good nucleophile, can come in and attack this carbon and kick up this entire group. And that's how we can convert our alcohol into the alkyl chloride. So this would work for both the primary and the secondary alcohol. And another reagent would be the phosphorus tribromide. And this would be a useful reaction in case that we want to convert an alcohol into the alkyl bromide. And this is how the mechanism would work out. So first, here in this case right here, we can see similarly to the thionyl chloride, this phosphorus right here is a good electrophile because it is bonded to 3 electronegative bromine. So the alcohol will be able to act as a nucleophile, come in, attacking it, and kick up one of this bromine right here. And once this has happened already, the bromine is now behaving as a good nucleophile, come in and attacking this carbon right here and kick off this entire Levant group, because this is now become a good Levant group. And that's how we can convert this into an alkyl bromide.